Here I've got a generator form which we're going to implement. Unlike a Python generator, we explicitly say the name that we want to use for yielding. So that's what this yield is. And this generator, created by make numbers, is going to be one that keeps yielding ever larger numbers. So when we make the generator, then we call it, we'll get 0, and then 1, and then 2, and so on. The way that this generator works is that it yields a number, and then it recurs with the next bigger number. So yield here is what causes the generator to pause and return a number. We've got the program over here. We can try out the code that we saw. And you can see if we keep calling g, then we keep getting more numbers out. So we're going to implement this generator form first with a little bit of sugar. We're going to turn generator and some ID with the body expression into make generator, where it's a lambda that takes that yield function, and then it wraps the body with an extra lambda wrapper to delay evaluation of the body until we're ready to start off the generator. So make generator takes this procedure right here, and it represents the generator as a new function that we call with 0 arguments. When you call that, then it's going to grab the current continuation. That's who it needs to deliver the generator value to, and that's what we'll use to eventually yield. In fact, we'll set the yield function so that it gets a value, and it's going to escape to this continuation carried here, captured there, with the value v provided to the yield function. But before yield escapes, it needs to remember where the generator is. So it remembers the generator's continuation and records that as go. So go is always going to be the current generator continuation. And it starts out as calling that original procedure, but eventually it gets set to each continuation for the generator. And so that's how the generator is able to feed new values to swap back and forth between the caller and the generator's implementation.